Okay, hello AS Chemistry students. Feedback on the KA7 that you did on Monday on rates and equilibrium. Couple of multiple choice questions. Question 1, which statement is not correct? Well, I've highlighted it. You should all know that the word is constant. They are not the same. All the other three apply to an equilibrium. Question 2, which statement explains why the rate of reaction increases when temperature is increased? So it's nothing to do with activation energy if you increase the temperature. The activation energy for a reaction is the same regardless for a particular reaction. Obviously what happens is the proportion of molecules exceeding the activation energy increases, which means the rate will increase. Okay, question 3. You're given an equilibrium. I've highlighted the first thing I do here is just point out to myself that the reaction is exothermic in the forward direction. You are asked to state one other feature of a dynamic equilibrium other than the fact that it's in a closed system. Yeah. So you could either have said rate of the forward reaction is equal to the rate of the reverse reaction, or concentration of reactants and products are constant. Okay, and then we're asked again about this equilibrium to predict and explain. Okay, so first of all, you predict how the equilibrium will change, the mixture will change when you heat it, and then you explain why you think that is the case. So if we heat it, it's exothermic in the forward direction, so it should move to the left. Okay, so prediction is it will shift to the left. The explanation is because the forward reaction is exothermic, moves in the endothermic direction, which is to the left. Again, predict and explain what effect, if any, an increase in pressure would have on the position of the equilibrium. So when we look at this equilibrium, we've got the same number of moles on both sides of the equation. So if we increase the pressure here, or decrease the pressure, if we change the pressure, there's not going to be any change in terms of where the equilibrium is sitting. So it will not have any effect. And the explanation for that is because there are the same number of moles of gas on both sides of the equation. Point out that it is gas. Okay. Question 4. Again, this is exothermic in the forward direction. Again, you're asked to explain that a statement is given to you. High pressure and low temperature gives the maximum yield. Okay, equilibrium yield of methanol. So that's methanol. Explain this statement in terms of Le Chatelier's principle. So take them one by one. High pressure will push the equilibrium to the right because there are less moles of gas on the right, and this will increase the yield because you're being asked about the yield of methanol, so mention it. Okay. Low temperature will push the equilibrium to the right because the forward direction is exothermic, and this again will increase the yield of methanol. And then explain why the actual conditions used by the chemical industry might be different. So high pressures are expensive to generate, so they'd probably go for a lower pressure, and low temperature gives a slow rate. So we probably find that industry will choose a lower pressure and a higher temperature to ensure a reasonable yield at a reasonable rate. Yeah? So just show that you recognise the connection between yield and rate. Okay, we're looking, the manufacturer of methanol uses a catalyst, and you're being asked to explain here using a Boltzmann distribution how a catalyst increases the rate of reaction. Yeah. Okay. So first of all, you've got to sketch a label diagram of a Boltzmann distribution. So you start in this corner, you go up, and you come down. You do not touch the x-axis. Label the axes. This is number of molecules or particles, and this is energy. Okay. Not enthalpy. It's energy. And then explain how the catalyst increases the rate of reaction. So I've marked on here the activation energy without a catalyst, activation energy with a catalyst, and then I've gone on to explain that catalyst provides an alternative route for the reaction that has a lower activation energy. As a result of that, you've got a greater proportion of molecules will have enough energy to react, and you can see that on the graph, so you can then comment on that. Okay, so EC is the number of particles with a catalyst, EA number of particles without a catalyst that will react. Question 5. So you're given again an equilibrium, it's exothermic in the forward direction. You're given some equilibrium concentrations of the substances in this equation, and you're asked to calculate a value for Kc. So the first thing you need to do is write your Kc expression. You need to make sure you're using square brackets. So we're taking the number of moles from the equation and making it a power. Okay, so we've got reactants on the bottom, we've got products on the top. The number of moles in the chemical equation are now powers in our Kc expression. Then we just take our concentrations and put them into these into this expression. We don't need square brackets when we're doing the calculation. Don't forget the power, which a number of you did. So you didn't get the calculation right. You got the mark for the Kc expression, but you didn't do the calculation correctly because you forgot to cube or square or whatever. Okay, so that's important that you take note of what you're transferring. Again, this is an explain question, how the following changes would affect the amount of ammonia present in the equilibrium mixture. So here's our equilibrium. If we add a catalyst, we're not going to get any more ammonia. We'll just get ammonia faster. Okay, so it would not affect the amount of NH3. And a higher temperature would push the equilibrium to the left, which is obviously in the opposite direction to what we want, because the forward reaction is exothermic. So that will affect the amount of NH3 present by producing less. Okay, so I should have actually said that. I think I should have made a statement here to say therefore there would be less NH3, because the question is asking you how it would affect the amount of NH3. So make a point of going back and looking at the question, which I didn't do here, and make sure that you've covered all points. Right, this question 6 has got a star here, which means that you've got to give a kind of full answer. You're given an equilibrium again, which is exothermic in the forward direction. You're asked to explain the conditions of temperature and pressure that could be used to obtain the maximum yield of sulfur trioxide. I've put a number 1 here. And then you are, so there's 2 parts to this, to discuss the importance of a compromise between the yield and the rate when deciding the operational conditions. So I've put a number 2 here just to show you where I've answered, how I've answered the 2 parts to that question. Okay, so I've explained about temperature and pressure, and I'm not going to read it all out to you. You can read it for yourselves. The conditions of temperature and pressure that would give us the maximum yield. But then I've also gone on to talk in the second part of the question to discuss a good compromise would be to increase temperature where there is an acceptable yield, even if it is reduced in a shorter space of time. Okay, so that's that one out of the way. This is about equilibrium. They're obviously all about equilibria and catalysts. So this is a reaction that you've actually seen I showed you on the video. Again, it's exothermic in the forward direction. You are asked to predict and explain. Again, you can see how common these questions are: predict and explain, or discuss. Okay, so if we compress the mixture, we are going to push the equilibrium to the side with the fewest moles, which will be in the N2O4 direction, which means it will go a paler colour, lighter brown or colourless. Okay, so because the question says would affect the appearance of the equilibrium mixture, so you do need to get both marks. You can't just say it's going to shift it to the right. You have to actually say that the colour, it would become paler in colour or colourless or whatever. Note that would change the appearance. And then the same here, if we put it in a warm water bath, it's exothermic in that direction, in the forward direction, it's going to shift it to the left, which means that it will turn darker brown. This is an equilibrium that it's actually in your books, I think, but I don't think we've talked about in class. But on one side is yellow, on the other side it's orange. And you are asked to explain the observation that if you add acid, the solution turns orange, and if you add alkali, the solution turns yellow. So you need to explain why that is the case. Obviously, if you're adding acid, you're adding H+. So the equilibrium will shift to remove that H+ that you're adding, and it's going to shift it to the right, which means it will turn orange, which is here. The part of the question that not many of you, if any of you, actually got is if you add an alkali to this reaction, it will react with H+, thereby removing it and forming water, which means that the equilibrium will shift to the left to replace the H+ that's been taken away, and therefore it will turn yellow. So this question you need to apply a little bit of extra knowledge there on your understanding of acids and alkalis. Okay, right, okay, so we're given an equation here. This is not an equilibrium. We're asked why, this is a rates question obviously, we're asked why mass is lost during the reaction, and obviously if a gas is being produced then that will be escaping, and that will mean that mass is lost. We're then asked to calculate how much strontium carbonate will react with nitric acid, and as we can see the ratio is 1 to 2 here. So we're given information that enables us to calculate the number of moles of nitric acid. As the ratio is 1 to 2, we have to divide the number of moles of nitric acid by 2, because for every 2 moles of nitric acid we only need 1 mole of strontium carbonate. And then we can work out the mass from the number of moles. Mass is number of moles times molar mass. Okay. And this one, some of you got a bit confused as to where to draw your tangent. If you're not sure, watch Boomer Chemistry video. He explains it very clearly. You're asked to give the rate at 200 seconds, aren't you? Oh, hang on a minute, I'm moving ahead of myself here. Let's just answer the first question. To describe and explain the change in the rate of reaction during the first 200 seconds. So the describing bit is to say that it's decreasing, and the explanation bit is it's decreasing because all the reactants are being used up. You need both those bits to get the 2 marks. And then the second part of the question is to calculate rate at 200 seconds. So rate is change in y over change in x. So first of all we need to draw our tangent. So you get your ruler, you bring it towards the curve until the point that you want is equidistant. Watch the Boomer Chemistry video, he explains it extremely clearly. I've drawn my tangent in, which very neatly happened to coincide with 96.10 grams there. Some of you didn't take note of the fact that this scale on this side, on the y-axis, doesn't begin at 0, begins at 95.90. So the difference between 96.10 and 95.90, as is shown here, is 0.20. So we take that difference, and then again we take this difference, which works out to be 280, sort of 0 to 280, yeah. Do the calculation, and it works out as 7.14 times 10 to the minus 4 grams per second. So pretty straightforward, as long as you've done your tangent correctly. Okay, and then you had to outline a method, and this again is a common thing now in exam questions, so you need to take note of the different methods that we've used when we've done practical work. So the method here must be mass loss. So you must be putting your flask onto a balance. Yeah, so you need to know the names of this equipment. You use a conical flask, you use a balance, you put the reactants into the flask when the mass is recorded at a time interval. You need to mention that, and you can give the time interval if you want. I would do it maybe every 30 seconds. using a stop clock again, so all the equipment that you would need for this has to be mentioned. It does tell you, and then once the mass is constant, i.e. the reaction stopped, then you can stop taking readings. Okay, so you've got to cover all the apparatus and the procedure here for your 3 marks. Okay, that's it. Not too bad. I think in general this paper wasn't done too badly. See you all soon. Bye.